Okay, good morning, everyone. What I want to do today is kind of finish up going over the steps of the scientific method. Up until this point, we've gone over the first three, ending with hypotheses, which, if we remember, was an educated guess or proposed solution to the problem. So the next step that we got to do is we got to experiment, which is testing our hypothesis. And within this step is quite a bit. Number one, it's an organized procedure for testing your hypothesis. Now, in some experiments, you might be asked to record a procedure in a step-by-step format. All right, but for our sake today, we're not. We're just going to kind of show you the types of variables that are in experiments, the two types of groups that are usually in experiments that you will see here in school. So the first thing is we have two groups. We set it up with an experimental group and a control group. Now, an experimental group contains a variable. Now, there are two types of variables. Okay, two types of variables. One is called the independent variable. Make sure you're writing this down. And the other one is called a dependent variable. So, whenever you're setting up an experiment, we need to know what it is we're testing. All right, so that is our independent variable. It is the factor that we are testing. And the dependent variable is something we measure. Okay. And on the next page, I will show you an example of how we identify the independent and dependent variables. Just a quick note, when we do set up our two groups in our experiment, the experimental group always contains the independent variable. Okay. Experimental group contains the IV, the independent variable. All right. The control group is something that we compare the experimental group to. So, for example, if I'm comparing two different flower pots and I add water to one and I don't add water to the other, well, that water is the variable that I'm testing. I want to see if water has any effect on the growth of plants. So in this case, water would be my variable. Now, if you just heard me say the growth of the plant, well, the growth is something that we're going to measure. So the growth of the plant would be a dependent variable. So in that example I just mentioned, the independent variable is the water. The dependent variable is the growth of the plant. So let's take a look at an example that's similar to that. Okay. All right. So my problem here is, does fertilizer affect the growth of a plant? So I got to set up two experiments. I got to set up two flower pots, one with the fertilizer in it and one with no fertilizer, because I want to see if fertilizer has any effect on the growth of the plant. So the fertilizer is my independent variable. The growth of the plant, which is something we can measure, is my dependent variable. And usually both variables are stated in the problem. All right, so again, independent variable is the fertilizer. The dependent variable is the growth of the plant. All right, so I have my two setups here. I have my flower pots, one with fertilizer, one with no fertilizer. I got the two plants in there. All right. Now there's something else that is very crucial when we're setting up these experiments, and it's something called a constant. Okay, now a constant, let me just adjust this here for a minute. A constant is something that both setups have in common. Okay, so when I look at these two setups, things that they have in common, well, they should have the same plant. All right, it wouldn't be fair to conduct an experiment if I have one rose and one tulip. So I want to make sure that they are both the same type of plant. So we got both two sunflowers here. We'll call them sunflowers. So they should have the same plant. They should be in the same size pot. All right, with the same amount of soil. Now the reason being is because underneath, all right, you have root growth. So it's important that the roots have the same amount of room to grow. I'm not going to put one plant in a tiny flower pot and one in a large flower pot. That would just give more room for one of the flowers to expand their roots and absorb more nutrients. So again, we want to try to keep these as similar as possible to conduct our experiment. The only difference here is going to be the independent variable. Everything else should be the same. Okay, so that's a key point. Both setups should be the same except for the independent variable so that we can isolate what it is we're trying to test. Some other constants that you're thinking of right now, maybe the same amount of light. It's not going to be fair to one plant if I put it in a closet and the other one by the window. So we want to make sure that we have the same amount of sunlight exposure. Um, the amount of water would be another constant. Okay, so I think you get my point. All right. So here, both of these setups, the control group, which is what we're comparing the experimental group to, because this one contains the fertilizer. Okay, the independent variable. All right, and then we have these constants when we're setting it up. So they both have the same plant, the same pod size, same amount of soil, the same light, and the same amount of water to give them the best chance to grow. The only addition is the fertilizer to see if it had any effect on increasing or decreasing the speed of the growth of the plant. So once we've conducted our experiment, we then go to the results section, which is step 5. Now, if at any point that I'm going too fast, you can always hit the pause button and catch up on the notes before you proceed. So here in step 5, once I've conducted my experiment, all right, and another constant might be is the amount of time. That's probably a key one. So I'm going to leave these plants to grow for 1 week. That's going to be my time frame. So I'm going to let both of these plants grow for 1 week before I record my results. So after 1 week, I can create a table. I can create charts. I can create uh, graphs. I could create a data table. With day 1, 2, 3, 4, 5, 6, 7. All right, and then just record the growth in centimeters. How tall was the plant? We'll call this plant 1 and plant 2. All right, how tall were they after each day? You know, um, this one with plant we'll say plant 2 was with the fertilizer. So I can record my data. I can make observations. I mean, I can clearly see if one is growing faster than the other. Um, and so depending on the experiment, you would set it up so that this is a good visual representation of what just took place, either by writing out general observations that you've made, any calculations. Calculations would be the measuring of the height of the plant. You could set it up, create a table, a graph. I mean, we could even create a graph, where we have, the days of the week and the height of the plant. And then, the one with the fertilizer, we might have seen this kind of growth. Um, so this was plant 2, and then maybe, plant 1, just didn't grow as much. So we can set up either a graph or a table. And next week, we're going to get into a little bit more graphing. All right. So that's what you do in step 5. And then step 6, you conclude. A conclusion is a summary of the whole problem up until your results. So I'm going to summarize the whole thing. You know, um, During this experiment, I tried to see if the effects of fertilizer would have any bearing on the growth of a particular plant. After a week of testing, I found that the plant with the fertilizer did grow in excess of 8 centimeters compared to plant one. So, based on my results, I can conclude that this particular brand of fertilizer does work. So, and that's how you would kind of end your your problem or your the whole lab. We could call this a lab report. We could call it a whole problem. Um, was my hypothesis correct? Well, yes. If I go back into my hypothesis, you know, it would be correct because I had said that if I add fertilizer, then the plant will grow. So, yes, my hypothesis is correct. I've summarized the problem. But now let's say the hypothesis was incorrect. Maybe the fertilizer didn't work. So I would have to go back to step 3, reformulate a new hypothesis, maybe with different fertilizer. Or maybe instead of fertilizer, I try sugar, just some other kind of variable that we could test. So that is basically the 6 steps of the scientific method. And if you have any questions, all right, you can ask me during class, or you can stop and pause the video and go back to make sure that you understand everything that is going on in the problem.